ByteDance has been on a real roll lately. First with their model Bagel, and now this. Today we're diving into Dolphin, a new AI that's built to do something incredibly tricky: read and understand the complex documents that hold so much of the world's information hostage. I mean, think about it. We are absolutely surrounded by information that's just trapped. It's locked away in reports, in forms, in scientific papers, you name it. And they're a messy mix of text, tables, images, and formulas. So the big question has always been, how do you get a computer to look at a messy picture of a document and pull out clean, usable data? For years, that's been a massive, massive challenge.
Well, it turns out ByteDance's new AI Dolphin has a really clever answer. It's a new multimodal model that's designed specifically to, read the fine print, to make sense of all that chaos so we don't have to.
And that gets us right to the heart of what I'm calling the document dilemma. These really complex layouts with all this mixed content, they make automatic data extraction incredibly hard. Your traditional systems, they just can't tell a paragraph from a table caption or a formula from a random figure. They get confused.
Okay, enough about the problem. Let's see this thing in action. Its power is really best understood by just watching it chew through some tough examples. And you're going to notice it's not just accurate, it is lightning fast.
So first up, we're feeding the model an image of a document, and it's got this complex table right in the middle. I mean, look at this thing. It's got merged cells, different text alignments. This is not some simple grid. This is exactly the kind of thing that would make most data extraction tools just completely fall over.
And boom, here's the output. It's not just a jumbled mess of text. No way. Dolphin has correctly figured out the rows, the columns, even those tricky merge cells, and it's rebuilt it as a perfect markdown table. Now this is the crucial bit, turning a static, dead image into live, structured data that you can immediately use. That transformation, that's what's so incredibly powerful here. All right, let's throw another curveball at it. Here's an image of a complex mathematical formula. The kind you'd find buried in a dense scientific paper. This kind of content, with all its subscripts and special symbols, is a classic nightmare for standard text recognition.
And this is where Dolphin's intelligence really shines. It spits out perfect latex code. Now, for anyone who works in science or math, you know this is huge. It's basically the universal language for writing formulas. It means the output isn't just a picture of the text, it's actual, editable, structured code that you can drop right into a research paper. Game changer.
So how in the world does it pull this off? Well, the magic is in this really simple but powerful two-stage process that the researchers call Analyze-then-parse.
It works like this. First, in stage 1, Dolphin does a quick page-level layout analysis. You can think of it like how you'd scan a newspaper page. You don't just start reading the first word, right? No, you scan the whole thing, you see the headlines, the images, the columns, you get the lay of the land first. Then, once it's done that, it moves to stage 2, where it dives into each specific part to parse the actual content.
Now that first stage identifies what the paper calls heterogeneous anchors. It's kind of a fancy name for a simple idea. These are just the different pieces of the layout puzzle, the text blocks, the tables, the figures. By figuring out where all these anchors are first, Dolphin can then process all of them in parallel during that second stage. And that parallel processing, that's the secret to its incredible speed.
So let's peek under the hood at the architecture. We can think of its two main components with a pretty simple analogy. You've got the eyes, which see the document, and the brain, which interprets what the eyes are seeing.
The eyes are a vision model called a Swin Transformer. It's fantastic at understanding images because it analyzes them in these small, overlapping patches. It's almost like it's zooming in on different parts of the page, but without ever losing sight of the big picture. Then you have the brain, which is mBART, a super powerful text decoder. Its job is to take all that visual information from the eyes and translate it into something structured and useful, like HTML for tables or LaTeX for formulas, and it can do this in both English and Chinese.
So the architecture is clearly very smart, but that's not the whole story. Let's get to the real secret sauce here, the thing that pushes Dolphin's performance right over the edge.
And the results on speed are just, well, they're clear. This chart shows Dolphin processing nearly 4 frames per second. That's way faster than its competitors. So it's not just more accurate, it's way more efficient, which is absolutely critical for any real-world use where you might need to process thousands of documents in a hurry.
So where does all this high accuracy come from? A lot of it turns out, is about using the right instructions, or prompts. So check this out. The researchers gave the model an image of a table, but with just a generic, vague prompt. And the model got totally confused. It thought the table was a formula and spit out a bunch of useless gibberish code.
But watch what happens now. They use the exact same image, but this time they add a specific prompt that gives it a little hint, basically saying, hey, this is a table. And just like that, the model knows exactly what to do and correctly parses it into a perfect HTML table. This ability to use these tailored prompts is what makes it so incredibly precise and flexible.
So what does this all add up to? When we put all these pieces together, we start to see a really clear picture of what this tech enables for the future, for how all of us interact with documents.
Here's the bottom line on why Dolphin really matters. It has true multimodal understanding. It gets both the visuals and the text. It's got that high speed and high accuracy. It handles the messy, complex layouts you find in the real world. It's bilingual in English and Chinese. And, maybe the best part of all, its creators have made it open source. That means anyone can use and build on top of this powerful tech. This kind of work is so crucial. It's about unlocking these vast oceans of data that are currently trapped in visual formats that machines just can't read. It really makes you wonder, doesn't it? With tools like Dolphin becoming more powerful and more accessible, what knowledge, once stuck on paper and in pixels, will be unlocked next?